welcome to my favorite test, the nth term test. You'll see this quite a bit the rest of the year in calculus. Basically what the nth term test is very similar to our testing for a sequence. We're going to take the limit of a sequence and see if it does not equal 0. So let me give you like an example. Let's say we have the following sequence, series, n equals 1 to infinity. And let's say we have something like 3n plus 2 over, let's say, 7n minus 1. And I want to find out this converges or diverges. Now, first of all, we got to recognize that one, this is not a sequence, so it's not our sequence rules. They don't follow. Secondly, we want to recognize, okay, the only other test we've talked about is geometric. This is not geometric. So if it's not geometric, we go on to a different test. In this case, we're going to use what's called the nth term. And here's what it says. It says we're going to take the limit. So I am just going to take the limit as n goes to infinity, and I get 3n plus 2 over 7n minus 1. And I'm going to take that limit. Now hopefully we remember from earlier that if you go into infinity, you only have to look at the common ratio. In this case, because it's 1 and 1, I get 3 over 7. Now, we're testing to see if it does not equal 0, which this doesn't. Now, what does that tell us? Well, the nth term says if the limit as a sub n does not equal 0, then it's telling us that the sequence, the series itself, will diverge. So our rule says because I get a finite, I get a number not 0 because 3 over 7 does not equal 0, we will say that the series diverges by the nth term test. And we're done. Now don't forget, you have to write down, here's my work, here's my answer, here's my proof. I use the nth term test. You just can't say the series diverges, the series converges, because it's a 50-50 shot. The AP won't accept guesswork like that. So you have to put down by the nth term test. So let's take a look at another example here. Here's kind of a fun one. N equals 1 to infinity. Let's take this one. N factorial over 2n factorial plus 1. This is kind of a cool one. Thumbs up. This is kind of a cool one. What we're going to do is we're going to again take the limit. The limit as n goes to infinity. But this time it's kind of hard. I'm going to get infinity over infinity, but I don't want to take a derivative using L'Hopital's rule. So I'm going to use an old rule. I'm going to divide by the largest power of n, which is just n factorial. So I'm going to divide everything by n factorial. You can do whatever you want to a problem, just as long as you do it to everything. And this becomes nice for us because the top just becomes 1, the bottom becomes 2, and you get 1 over n factorial. That just goes to 0. So we get 1/2, which again is not 0. And because we don't get 0, we can say therefore the series here diverges by the nth term test. And there's our answer. So let's take a look at one more example, and then we're going to take a look, then I'm going to really kind of blow your minds here today. Okay? Let's try this one. N equals 1 to infinity. Let's say we have something like, I don't know, 7 to the n plus 2 over 7 to the n, just 7 to the n. Let's just leave it like that. Alright, so if I try taking the limit as n goes to infinity, we're going to get 7 to the n plus 2 over 7 to the n. I get infinity over infinity, which means L'Hopital's, right? So now there's a shorter way to do this one, okay, other than L'Hopital's, other than taking those derivatives. And I'll show you that in a second. As n goes to infinity, if I use L'Hopital's, the top one, 7 to the n times the natural log of 7 over 7 to the n. Now, if I notice this, what happens? The 7 is to the, natural log of 7. Everything cancels, right? And I get the limit as n goes to infinity of just the number 1, and I get 1, which, again, does not equal 0. Therefore, we say that this series diverges by the nth term test. Now, of course, an alternate way, I could have just split my fraction here. I could have written it this way, as n goes n goes to infinity of 7 over n plus 2 over 7 to the n. Well, if I rewrite it as n goes to infinity, I get 1 plus 2 over 7 to the n, which again is 0. So I get 1, which again does not equal 0, and I get the same answer. So another way you could do that one. All right, now, there's a danger for the nth term test, okay? And this is going to knock your socks off, okay? This is that nth term test. Now, recall, okay, the nth term test. Now, I want you to write this down. Only tests for divergence. Okay? The nth term test only tests for divergence. Now, what that means for us, very simply, let me see if I can get this down here, rotate it here. I won't be able to. Sorry. What that means for us is that it does not test for convergence. In other words, if the limit as n goes to infinity of a sub n equals 0, when you're doing the nth term test, if this equals 0, we say the nth term fails for now. The nth term fails. Okay? In other words, we will need another test, which we're going to be talking about later on. So if the limit of a series, and this is for series only, remember this is only for series, not for sequences, for series, then we say the nth term test fails. Now, it's kind of like a pregnancy test. A pregnancy test only tests if you're pregnant. If you take a pregnancy test and it comes back negative, it's not saying you're not pregnant. It's saying you need another test to find out. And you can go to the doctor for that. They have better tests, more accurate tests, and things like that. For example, my wife and I, when we wanted to have another kid, we took a pregnancy test. It came out negative. Now, I can assure you, nothing happened in between. But what happened was, 2 days later, after that pregnancy test came back negative, my wife took another pregnancy test. Came back positive. The same thing is true for the nth term test. It only tests for divergence, not convergence. If you get 0 for your limit, we have what we say, just say the nth term failed, and we go on to another test, which we'll talk about later on. Now, to give you an example, what if we have the series of n equals 1 to infinity of 1 over n? If I try taking the limit here, 1 over n, I get 0. So what this is saying is that the nth term fails right there. So we will need another test. So we can't, this is inconclusive, you could say. So, as a matter of fact, this is what we call a harmonic series, like harmonic motion. This actually will diverge. Even though we get 0 here, this one still diverges. Another test when we talk about the p-series will tell us that. So it's very, very important that we kind of make sure that we understand the difference between all the tests. Now, as a sequence, be careful. As a sequence alone, this will converge. So I don't want you to get too confused. This is a series only for series. Okay? So I'll see you guys in part 3. We're going to talk about telescoping series soon. All right? Bye-bye.